All right, folks, I appreciate you taking the time out of your busy day to join us today to talk about threat hunting with APM. My name is Ruben Perez. I'm a senior solutions architect at Elastic, and I am one of the three SAs that help within the Sled organization, that's state and local government and education. So if you have any questions during or after this talk that come to mind and you didn't want to leverage the chat, feel free to hit us up at sled@elastic.co, and it'll go to each of us, and we'll do our best to answer promptly. So without further ado, I'm going to jump right into it. So I hit on it, if you're around with the housekeeping intro. Due to the current state of affairs, everybody's thrust into this distributed workforce mode. If your organization was prepared for it prior to the COVID-19 pandemic, then good on you. We were lucky enough to have a good infrastructure in place where we can sustain a distributed workforce, but not everyone out there had that in place. And what that really means is now they're scrambling to make sure that they can do their day-to-day as efficiently as they were when they're traveling into the office. That's always not super easy, especially if you don't have the proper tools in hand to do that. And so a couple of things that have propagated to the top of most of my customers' wants and needs during this time, and not just prior, but specifically during this time, is security and making sure that their enterprise, their infrastructure, their network, their applications, everything is performant. They want to make sure that they're doing stuff as optimal as possible, still in a distributed workforce, and being secure about it. Because now that you're all out in the ether, you expose yourself to potential malicious users both in and out of your enterprise. And so that plays nicely into what I intend to talk about today. Sort of a two sides of a coin, if you will, but I'm going to primarily focus on our application performance monitoring, or APM for short. That's the tool, or that's the solution that's a part of our observability stack within our Elastic solution suite, and I'll get to that in a little bit. But effectively, it helps you make sure that your code and your apps are performant, and it checks those metrics in real time. It can also go a step further and make sure that your code is not hitting any unexpected errors, as well as provide sort of rudimentary host information where the APM agent is actually running. And I'll get into the agents a little bit more. What this component sort of shines, especially with our latest release, I believe as recent as 7.6, we can now leverage the data that is retrieved from our APM agents and that is sent to our APM server. And we can extend that to our SIEM solution, so we can do further analysis and threat hunt against those malicious users that I mentioned a few moments ago. And I'll show you guys, both from a slide perspective and a back-end perspective, how that all looks and how the correlation between the two applications happen. So here's a brief overview of our Elastic solution suite. We like to call it our 3+1 model, the 3 being the Elastic Search, Elastic Observability, and Elastic Security. And the +1 is our stack and deployment options. We can be deployed both on-prem and in any cloud of your choosing. And we also do a hybrid. So whatever needs you require, we can fit the bill. As I mentioned, the APM component lives under our Observe stack, but because of how all of our components correlate, it's easier to see how the quote-unquote borders sort of blend into each other, where the same data set is leveraged in search and or security for whatever your end user needs might be. Here's a brief overview, an architecture abstract, if you will, on all the various places that you can deploy our APM solution. It comes in two parts. You have your APM agent that lives next to your apps and any of the components that you're looking to track from a metrics and performance and error handling perspective. And that data is retrieved from that agent and then sent to an APM server that would live in your Elastic cluster. Again, that could be on-prem or in the cloud. And this is a visual showing you just APM can be on your app side, middleware side, as well as your logs and information for uptime to send those metrics to the APM server. Brief view of what we support from a technology basis. Now, this is growing. I do believe, and don't hold me to it, but in near future releases, we might extend what we are supporting. But as of now, we support the big programming languages, Java, Python, .NET, Go, Ruby, Node.js, as well as within our real user monitoring, we support JavaScript and the various browser and mobile device flavors that you can choose. Now, why does any of this matter, right? I mentioned that everybody's thrust into this workforce, the distributed workforce, and if you weren't prepared for it, you're scrambling. Even if you were prepared for it, how do you know that your system is behaving as you desire? How do you know that it's as performant as you wish? How do you know that you're not hitting errors that otherwise you might not have known or been alerted to? And why does that matter? How can that prevent potential ransomware by an internal disgruntled employee because they're working extra hours, and so they're doing intrusion attacks or malware or ransomware through their code that they're in their DevOps? Or you have malicious external users trying to hit your website and doing injection attacks that then gets unexpectedly deployed when that search button or that actionable button on your website is clicked. All these can hit an enterprise and hit a network hard, especially if you're not built for a distributed model. It could eat into an already tight budget. I'm sure you guys are well aware, both from a local government and state government, as well as a higher ed. Budget's tight these days, especially because of the COVID-19 lockdown and the fallout from that. So APM and SIEM that I'll show you in a bit can really help mitigate those unforeseen risks so that you can be more proactive instead of reactive. Because at the end of the day, if you're reactive, you're already too late, and you just expose yourself to more and more faults, right? So getting back to the APM component, it spiders into a bunch of our different solutions, as I mentioned, one of which being our machine learning capabilities, as well as our alerting and watcher capabilities. And all that's to say is that machine learning helps you within our stack find that needle in a haystack without you having to dig for hours and hours and hours on end, or maybe days or weeks. And it can reduce the amount of people digging for a particular issue that machine learning might expose to one person instead of a handful or more people. And what happens is a machine learning component will detect anomalies based upon the data set that you send to Elasticsearch. Anomalies can be positive or negative depending on your enterprise needs. For example, within a store perspective, an anomalous event could be an uptick in purchases or buys. That'd be great. Bringing it more home to the Sled space, an anomalous event could be a higher traffic of college, for example, with registrants wanting to go whenever school opens up again to be a student. That would be a positive anomalous event. A negative, a little bit easier to decipher if there's no traffic going on in your site that you expect, or you see your code is taking way too long on a particular transaction, or things along those lines. A machine learning component will alert you to that, and not just from a visual perspective, but we could actually send messages, whether it be through things like Slack or email, or potentially even leverage webhooks to go to a ticketing system. Watcher is something similar, not quite as in-depth as machine learning, but it's effectively you set up a definition, and should that event happen or trigger, you can be alerted again through email, message, or a ticketing system that that event occurred, right? This is what a visual would look like, and we'll touch on this briefly during the demo portion. But within our system, whenever something is considered anomalous, the brighter the red hue, the more anomalous the event has occurred. And it's just bringing your attention to that particular piece so that you take action on it before the others, because it's a higher priority. Now, how does APM information sort of play into our threat hunting with our SIEM solution? I mentioned before, you have potential errors in your code, rightly or wrongly, or intended or not intended, that can be exposed from our SIEM solution. And by that, I mean, again, if you have a disgruntled DevOps person that's injecting malicious backdoor information that allows them access to your network outside of the network, they can get in, pull what they need, and then be malicious about it. That's one way of an internal attack that an APM component can track any code anomalies, errors, what have you, leveraging our machine learning as well, and feed that data set into our SIEM solution. Again, as recent as version 7.6 is when we can now leverage the APM data within our threat hunting capabilities. We can use that information so that we can get to our root cause, mean time to resolution, way quicker. Without it, it might just be an error in our DevOps code that might go unnoticed, and people might shrug it off and say, well, let's just fix the error and move on. It might not be an error. It just might be a backdoor thing where nobody is made aware except for the malicious user. Again, APM, our machine learning, and then our SIEM threat hunting capabilities can actually expose those weak points and failures, and your SOC team can take action upon it. We at Elastic like to leverage our ability to include the Mitre attack framework. If you guys are unfamiliar with it, we do have a portion of our website that talks about how we include and leverage the Mitre attack. Effectively what it is, it's different known malicious attacks and various techniques associated with each attack. Now, as your APM data is processing by the agent and then into the server and eventually into Elasticsearch, you can apply things called signal detections that are located within our SIEM application. And those detections can leverage Mitre attack frameworks. And the way it goes is you define your signal detection, you call out the Mitre attack that you are looking for, and the particular techniques that attack would be associated with. You can pick one, many, or all techniques. It really depends on how you want to define your signal detection. And how it goes is this: as the APM data gets funneled into the system, the Elastic system, should any of these signal detections be triggered, you will get various alerts within our SIEM solution, both from a graphical visual perspective, as well as, again, send messaging, emailing, and webhooks into ticketing systems. And we'll go through an example of this. I actually have my system running in the background doing placeholder or dummy attacks so that we can see within the demo environment how it looks from a visual perspective. And that's a good segue. Let me jump into the meat of it here. So I mentioned I have my various backend components running. I have a slew of beats. Those are our data retrievers for those who don't know. And I have a basic Python script that's leveraging our Elastic APM Python agent. And the agent is sending data specific to my code and the functionality that my code is doing, and it's sending that to the APM server up in my cloud instance. I mentioned before we can work on-prem or in the cloud. I chose to do a cloud version of this. Quick note of the cloud deployment. For those who haven't used our Elastic offering, I would urge you guys to get your feet wet with our cloud deployment. You can deploy a cluster within minutes by the click of a button. And I believe it's a 14-day trial. And if you like what you see, you can talk with some of our reps to extend that trial. If you prefer to work on-prem, we do have basic functionality within our open source accessibility within our Elasticsearch system. You can download any of this software if you're doing on-prem from our elastic.co website, as well as associated documentation. So let me quickly go into my APM system. So what we're looking at here is our user interface. For those who have seen Kibana before, would you throw a few pluses in the chat just so we can, well, not me, but my counterparts can at least see who knows what I'm showing. So what we have here on the left-hand nav is a bunch of our solutions that are available to our end users. Again, if you use our cloud offering, these features are all exposed during that trial license. The on-prem basic license would be a little bit different. You might, again, have to work closely with our reps to expose some of these specific features, such as machine learning and some of our alerting features. What I have here is an APM agent, again, running on my Python script that is right, no, that's my packet beat, my apologies. Let me see if it's still going. Yep, all right, so what I'm doing here is I'm targeting various websites, and I'm doing searches for a particular string on any of those websites. If the string exists, I do some stuff. If the string doesn't exist, I do some other stuff. I capture exceptions and whatnot, and I send all this information to my APM server in my cloud cluster. I called it test environment agent so that it's easier for me to see. Go ahead and update. So a couple of things that you can see from here. You can alter the time span for which your data is being presented. It could be the last 24 hours, last week, last 7 days, oh, same thing, sorry, 30 days and whatnot. You can do a custom, anything from seconds down to years. Whatever the time frame you want, you can get. And so I'm going to put it up, live environment. So my apologies. Let me refresh. There you go. I have data coming in for the last 15 minutes. Now, what I want to do is make sure that my metrics are coming in from here. Yep. So we can see if I have this update every 5 seconds, and I'll let it run for a couple of seconds so you guys can see sort of what's going on here. All right. It's flowing through. I don't know if you guys can see it, but it is gradually flowing to the left here. As of our recent version 7.7, we've exposed something called service maps within our APM agent. And this is pretty cool because it gives you a visual of what your code is doing out in the world, right? So my particular code, as I mentioned, I'm going out to various websites and trying to search for a particular string, but this can also show if a code app is going to other code apps It could show if it's going to other repositories. Whatever the code is doing, the agent can encapsulate that in a transaction form that'll be displayed within our service map. And as I mentioned before, we do leverage the big code options. Let me move this out the way. So that's our service map, and that's as recent as 7.7, which just dropped, I want to say a week or two ago, if I'm not mistaken. So let me get back to my transaction. I just want to make sure I show you guys that. So within my code, I have a few different functions that are going on. I name them differently so that I can track the information differently. But each will show my time spent by the span type, as well as various metrics for the APM functionality that's going on. It shows me exactly what's going on within that function from a time perspective. It took X amount of milliseconds and whatnot to complete. Generally, I want to see stuff in the quicker range because our solution is based on one of our 3 core functions is speed. So if there is something that's taking longer than expected, I usually jump to that immediately. So a few pluses in the chat if you guys are familiar with APM. I probably should have asked that before I showed this. What we're seeing here, in addition to the metrics that I showed up here, and the ability to see the service map that I showed earlier, we can see the actual stack trace of what's going on. Now, if I were doing more calls and more technical detail in my code base, you can see additional API calls. I reach out to an API that reaches to a backend server. That server then has particular select or request commands to retrieve that data set, and then it's all propagated back to that API initial call. Right now, for this particular call, I only have 1 instance of the stack trace that was shown right there, but that gives me key information on what's going on from my agent's perspective on that particular transaction. If I were to have an error, let me see if I can find an error transaction. Go back to transactions. My website download has a few errors in play. You see that this one immediately, because this isn't just housed within my app, it actually goes out to the internet. It shows that there's HTTP calls as well as app requests. And this one, I believe I do have an error. Well, maybe not. Maybe I cleaned up my code well. Luckily, I do have our other environment. By the way, if you want to play with any of this stuff on your own, or at least get a visual on this, I would urge you all to go to demo.elastic.co. You can actually see what some of our key features can do. It'll be difficult for you to customize anything because, again, this is open to the masses. If you do want to do custom testing and whatnot, again, cloud.elastic.co, sign up for a trial version and give it a go. Let me go in here and see if there's any errors so you guys can at least get a visual of it. This is taking a while. It loads my stack trace. No, Python's happy. In any event, it'll display a red error mark, and you would go ahead and select that. And similar to when you select the stack trace, it would show you where within the code line X of function Y in script Z that error occurred. It's going to give you additional information like the error message if you're tracking that sort of information. All that would be displayed within the same APM window. Gone is the day where you have to go and check your logs for a particular error message and then come back to the stack trace, see what called it, then correlate the timeframes. All that's presented to you in a nice, concise format. What you can do, though, if you did want to go see where this event might have been logged, you can jump from our APM view to your logs view, or your metrics view. So this is part of how our various components, even though they might show the data differently, they are leveraging the same data under the hood, and so we can correlate easily between the two. What I would like to show also, I touched upon it in the demo, in the deck. If I see something that's of interest to me here, and I want to go ahead and create a machine learning job from it, what will happen is, with the click of a button, I would go ahead and generate a machine learning job that checks anomalous events for this particular APM transaction type. So if normally this transaction, I don't know, takes 1 second, if for whatever reason on one particular day it took 20 seconds, this machine learning job should alert me that there was an anomalous event. It was well beyond the expected norm. And if I have the ability to hook into any ticketing systems, or if I want to send a message or an email for it, I can do it right then and there. Similarly, I can do alerts and the watcher that I mentioned. I don't have any existing watchers nor alerts, but I can do one on the fly here. We can check it out. Again, I can call it what I want. I can have it check every, I don't know, I can have my alert check my code in my system every minute. But if I have hits or if I don't have hits, either way, I don't want to get spammed every minute. So I can be notified every, I don't know, hour, every day if I want. Or if you really want to hound yourself, you can have yourself notified every X amount of seconds. But the key takeaway here is you can have the alert check your system more frequently than you're alerted to potential hits on the alert. So you won't have, in the course of a minute or an hour, 20, 30 different messages or emails or tickets generated through our webhook thing. And as you enter information up here, it's updated from a what's going on perspective down below. So we really are trying our best to show you guys or provide you guys the ability to see your data, understand your data, ingest your data, and then take action upon that data as quickly as possible. Again, the action could be from a proactive approach, you're trying to prevent X, Y, and Z from happening, or it could just be from an approach where you want to optimize the performance of your system. Again, leveraging things like our stack trace would show how performant things are going. I'm going to show you this demo.elastic.co stack trace just because it provides a little bit more meat in terms of the stack trace. So you guys get a nice visual of what it could look like. Let's see if I picked the right one this time. All right, nice. And this one has errors as well. So as you can see in this APM request, this is a Java applet, I believe, that it's targeting. There's a dispatcher servlet request. And that request, that HTTP request spawned the op beans for Ruby, which then spawned these various API calls. But this Ruby request took so long that these calls really didn't have much time to finish. And we do see that there are errors involved. Let's go to the rootmost one. This is what's going on in that request to that database, it looks like. But yeah, so what I wanted to show you again is how this stack trace can grow depending on how complex your code request is. Again, that could be an API request, that could be a OS request, that can be a browser HTTP post get request or something like that. Whatever the request is, it'll show within our stack trace here. All right, let me go back to my system. So, all right, so I think I showed you various ways on how APM looks and feels in the various data that it can bring into the system. So let's see if we can marry this to the other side of that coin that I mentioned earlier with our SIEM. Go ahead and click our SIEM. And if you're not familiar with our icons as they pertain to our various solutions, by default, the left nav is collapsed, but you could always expand and see what function you want to do. So we're into the SIEM solution now. I'm going to update my calendar to show for the last 15 minutes. And if I wanted to be really continuous, I'm going to have it check for new data every 5 seconds. So what I'm being displayed right now is any signals or any SIEM information that's been processed in the last 15 minutes. And oh, by the way, I want to refresh that data set every 5 seconds. So I mentioned before, I made dummy signal detections. And by dummy, I mean, because I'm not, this is running on my laptop and I'm not trying to maliciously attack myself. But in a real world scenario, hopefully you don't see too many signal detected. But if you do, you'd be presented with all of them in this initial overview page of SIEM. Now that's the first thing that pops out, at least to me, but there's quite a bit of other information being displayed on this page. Something that is recent as of 7.7, I believe as well, is this notion of cases. And what that is you can basically add information that's presented to you in your SIEM, whether it be through timeline information, which we'll get to in a little bit, as well as host network and detection information. And you can build a digital case to say, hey, you know, I've seen this. This looks like it's of interest, at least to me. I want to share this with my fellow security folks so that we can collectively decide what action to take on it. So any recent cases that you might be associated with or have open would be displayed to you here in your top left area. Timelines, that's a way to build a visual of the data that's stored within or that's being displayed within SIEM, but that it culls that data set down to particular filters that you add to your timeline. And so we'll do this in a few minutes, but what that does is you have your whole entire data set, you add a metadata value to your timeline, and it calls the data set to everything that contains that metadata value. And then from there, you can build Boolean and or queries to continually call that data down so that you can potentially get to a malicious or problematic event quicker. And like cases, you can save your timeline so that you can come back in. You can potentially share it with colleagues so that they can pick up where you left off if you're working with a round-the-clock SOC analyst team where someone comes in the morning, they leave at night, and then they hand it off to the next person. You can share this type of information with your teammates. And we also provide any sort of security news that we are presenting within the elastic.co website. So anything security related specific could show up here. So again, you don't have to have 20 different tabs open. You can sort of just pop out from this individual view all the information that you might want. I don't have any external alerts, but similar to the alerting that we mentioned earlier, this would let me know if and when anything's going on for the particular time frame that I selected, any alerts that I should be aware of. From an event perspective, what is going on my server? I see that I'm doing a lot of TLS and DNS requests, HTTP requests. There's different flows going on. So this event tracker is just doing a count of the various goings on that's happening on that server that's being tracked. And it gives you a high level overview of the various data retrievers. We call them beats in-house. But if you have a custom way to get data into Elastic, assuming you do it in the Elastic Common Schema format, you can expose information like that from your host and or network level. So let's go ahead and check out briefly the 10,000 foot view, if you will, of the SIEM solution. And so what's going on here is it's showing me the network communication between my server that data is being retrieved from, again, my laptop, and where it's going to. What all is going on in my laptop? How many DNS queries, if any, am I doing? Any TLS handshakes and so on. And you can see the various source IPs that I'm generating and the destination IPs I'm going after. Let me stop this continual thing. Otherwise, this page is going to continually update. So we can get a sense of what we're looking at here. Again, if you marry the machine learning into any of our solutions, we have the sense of anomalies, and we would display them if the jobs are presented. I don't have any jobs set for my SIEM solution, but again, if I were to set one up and an anomalous event would trigger, you would see the anomalous score, the particular job that you stored that machine learning at, and any influencers that are triggering that anomaly. Here are my DNS, HTTP, and TLS requests. Now my code is doing a whole slew of DNS requests. That's by design. Depending on your server, I'm not sure if it should be this chatty. It might be a prime example of a server that you want to take a little bit more deeper dive into and see really what's going on, making sure that whomever is on that server isn't doing anything malicious. And here are the various domains that I'm trying to target. So that's at the network level. I can see where in the world these requests are going and coming from. If I had a network of multiple endpoints. But let's just say I want to target a specific host. Now that's easy for me because I only have one host in my network for now that I'm tracking. But you can imagine that this would be chock full of a list of hosts that are presenting data to the Elastic system, given our various ways of retrieving data. Similar to the network side, we have an anomaly. So if you have machine learning jobs that are targeting hosts instead of networks, or in addition to networks, you can be presented with that information here. Any authentication requests to that host, if you have any success or failures, you want to be alerted, especially with a success could be a key point of interest depending on who the successful authenticator is. An example of that would be someone who had their username and password stolen or otherwise taken without their knowledge. Their credentials could be leveraged to authenticate to a server that they didn't authenticate themselves to. So that sort of information would be highlighted and triggered within our SIEM solution. And again, through alerting and whatnot, your security team can be proactively made aware so you can go out and threat hunt on that particular malicious event. And if there are any uncommon processes, my code, I think I'm generating a bunch of just certification files to make it look like I'm being malicious. And quickly, I want to show, luckily I had a couple stored here. So here is an instance where I brought over a source IP into my timeline. I'm gonna add more information now for just visual sake so we can see what's going on. And then I'm gonna hopefully bring it all home and show you how the APM data itself can be leveraged to drive this functionality within our threat hunting capability. So let me remove that. Cool thing about our timeline, you don't have to type anything, you just drag and drop. If you close the timeline, it sort of collapses, so it's not really blowing it away. If you jump into any of our other SIEM links, I guess if you will, hyperlinks, it's within a tabbing, if is the best way I could describe it. But notice that my timeline still persists. It's staying within my session. If I were to kill this browser or this tab, then without me saving or favoriting that timeline, it would go away. But I can go ahead and drag and drop stuff, close my timeline, and go to another window, open my or another view, open my timeline, and it still persists. So that's a general overview of how our SIEM threat hunting could work. What I want to show you guys is the signal detections that I mentioned, because that's where the APM data that the APM agent is grabbing can come into play. So I have a few already generated, and I'll just click on one. And so what's being displayed to me here is a few key information details for this particular signal detection rule. And again, if this rule triggers, then I can have something happen. Right now, I'm not being alerted. Otherwise, I'd get an email or a message. I think my code runs every 5 seconds. I definitely didn't want to spam myself. But you can have these signals trigger a messaging of sorts if the detection rule is found. And so what I did here was I just cherry-picked various Mitre attacks and specific techniques for said Mitre attack. And I use that information, and I have these hyperlinks that allows me to jump to a more descriptive page within Mitre itself on what that attack and technique means. But I'm using this to detail what this signal detection is going on. So if any of my colleagues were to log in and see a new detection rule in place, they're presented with as much information as I could provide them on what this signal detection is about, how severe I deem it, and a risk score that I want to give it. I can tag it with anything that I want. I can add APM, which I already have. I can add Rubin's detection. I can add HR detection rule, whatever you might want to leverage to filter later on from a detection rule perspective. You can add as a tag and cull down the amount of detections presented to you, so you can see at a quicker rate what detection of interest, or what detections are available and maybe of interest to you. Now, by default, I think once you deploy our SIEM solution, we have roughly 100 plus default signal detection rules in place. And I do believe it's ever growing. So as new and interesting ways of malicious attacks are found, we do our best from an engineering perspective to build out those rules for you. So you can really plug and play. You turn this thing on, and as long as you activate the rules, everything is ready to track your system from a threat hunting perspective. This particular rule, not just what it's about, but the core definition of it, tracking any APM data that's coming into Elasticsearch, and that's denoted by the index pattern that I select. For this data set, I'm looking for a metadata value, a metadata attribute that has a value of SSH key generator. Our data is generally stored in key value pairs, JSON format, if you will. So the metadata attribute that the APM agent is sending over is a transaction type, and the particular value of that transaction type that I want to track for this signal detection is this key generator. And I have a frequency in which I want that to run. So I think it defaults to 5 minutes. It checks the signal detection. And if you want to look back any point, any additional look backs in time, you can add that additional frequency. Now I stopped the continuous flow of updates to my page, but if I were to turn this back on, you would see this bar chart continually scroll to the left as new and other signals are detected. And here are all the instances of when that particular signal detection was triggered. you can see it's a lot because I have it running continuously in the back end. I can see additional attributes of the information that's presented to me, a la the metadata that the agent is presenting to the SIEM solution. So I can leverage this to build more of a timeline saying, you know what, I want the host IP to be in here. And notice that I put it under, so now it becomes a Boolean OR. If I get rid of these, now we're back to this single component. Let me see if I add that. Yeah, I would have to fix my time range to see all the instances of where this host IP and this host name exist. Again, it's not bearing too much fruit because everything is originating from my laptop. But if you have a network of hosts, you can see the correlation between host-to-host communication, host-to-outbound network communication, or inbound network communication to any particular host. Now let's do a quick generation of a signal detection before I open up for Q&A here. So off the bat, I'm presented with any of the index patterns that are within my system. I'm going to get rid of, oh, I see someone raise their hand, Harav. Is that an accident, Parab, or let me see, where's the chat? No Q&A open. Parab, I'll get back to you in a sec. Let me just show the signal detection creation. So I'm gonna remove any of these unwanted index patterns. Again, they're coming from my various beats. And I just wanna focus on my APM data. I can even go a step further. Instead of APM dash star dash whatever, I can just do APM dash star, and that'll get me all my APM information instead of just transactional data. Now, let's say I don't know all the metadata attributes that are coming in from my APM agent. I can go ahead and scroll through all of them, or I can type in something that I'm interested in and see if there's a metadata attribute that exists. So I see that there's error messages, error types. I'm gonna click error message. Now, if I wanted to know specific error messages that are existing, I can just go ahead and click through. But let's say that I just wanna check to see if an error message exists. I'm gonna go ahead and continue from there. And this is my test name, my test description. So this is where you would write up all the key details that your colleagues and yourself might want to know about the signal detection rule that you're generating. The severity that you want to allocate to it. If you feel like it's something that'll happen frequently, but you still want to keep track of it, I would recommend giving it a low. If it's something that's mission critical, of course, give it a critical severity. And at that point, I would give it a 100 risk score. I'm going to tag this APM as well as my test. And advanced settings, this is where you would apply the particular Mitre attack that you're tracking. So I mentioned before, you can select any of the known Mitre attack frameworks as well as their associated techniques. So you do one, many, or all. I'm not going to click through all of them, but you get the gist there. If I hit continue, again, I can have this signal detection run every X amount of seconds, minutes, hours, and I can have a look back period in case I think I might have missed something prior to me generating the signal detection for X seconds, minutes, hours. And this rule action, again, for me, I'm not going to do it, but on each rule execution, or you can have an hourly, daily, weekly function where it can message you either through email, through a messaging service like Slack, or a webhook that can go into a ticketing service or potentially another messaging system. So let me perform no actions there. Now I can create the rule without activating it. And what that means is I think this rule is good, but I want to do some research before I actually turn it on within my system. I can save it and not have it do anything within my system. The alternative would be to create it and then automatically activate it. And let me look at my tags. If you notice, the tag that I gave, APM my test, is there. Let's say I came back, I did my research, I'm happy with the way I developed my signal detection rule. I'm gonna go ahead and activate it. Now, once it's activated, any subsequent trigger of this rule, as well as any look back trigger of the rule, depending on my look back time frame, would show up in my signals detection chart. And you can edit the rule, duplicate it if you want to use it as a foundational piece for subsequent rules. If you think the rule is erroneous, you can go ahead and delete it and whatnot. And so what? What does this all mean? The APM data that we pushed into the Elastic system no longer is just used by your DevOps team. It can now be leveraged by your security team. DevOps can leverage it to make sure that the code and the apps and the functionality of the backend system as a whole is performant. And your security team can make sure that no malicious activity is going on specifically with that APM data. I want to go ahead and pop out for a second. That was, hopefully that showed you guys a good understanding of how our APM data by itself is critical in bettering your system as a whole, but it takes it that much further by pushing it into our security solution and allowing two otherwise exclusive teams for the most part to now work collaboratively. And by that, I mean the DevOps and the SOC team, the security team. I'm going to get to questions in a second, but if you guys enjoyed what you heard today and are interested in hearing a bit more about what we do at Elastic, or if you want to represent your community at the next virtual group, you can please check out our website at community.elastic.co/state and local government and education Sled virtual. And quick shout out to my counterpart, Jenny Morris, will be doing the next virtual group in a few weeks in June. And that one's going to be around leverage Elastic machine learning features to enhance your security posture. So hopefully a good segue from my SIEM discussion into how machine learning is used to better your security posture. If you want to learn a little bit more about Elastic in general, we have various training subscriptions and options for you. I mentioned ways to get at our system, both from a demo.elastic.co as well as cloud.elastic.co, so that you guys can have hands-on experience with the solutions that we have to offer. That way, if it piques your interest, you know where you want to learn a little bit more on. Now, yeah, well, thank you guys for your time. I wanted to give a few minutes for questions. I know I pushed up on the clock there, but okay, I see, Prav, that was in fact a mistake. Thank you. No questions. Either I did a good job explaining everything, or or something else. If you guys are shy, don't want to put questions out there on the chat or in the Q&A area, again, feel free to reach out to us at sled@elastic.co. It could be about anything. Again, if you want to have a more directed topic of your choosing, we do take requests. We can't promise that we can build a whole talk track around it, but if it fits within our narrative, for sure, we'll make sure that we have our community's voice heard.